Welcome to our presentation at the Congress in Porto, Risk Management for Large Infrastructure Projects. My name is Philip, and this presentation was put together with my colleague Arno. We just want to introduce our company, Risk Consult, then have a look at the risk management objectives, the problem definition for major infrastructure projects, and the digital project risk twin with some examples. Our company, Risk Consult, is based in Innsbruck, Austria. We are a small company specialized in cost and risk management for large infrastructure projects. I want to show you some of our references. Also, some of the projects use the methods I want to show you today. Here, mostly in the sector of large tunnels, high-speed rail, airports, power plants. And also a large field of application is also the subway sector, tunnels in large cities like here in Vienna, Munich, Hamburg, New York, San Francisco, or Ottawa, Canada. First, we'll have a look at the risk management objectives. So we can see the slide here, and you see those three columns, which depict mainly the project management in mega projects. We have on the right side the budget planning, the project cost control, and in the middle and on the left side the risk management. Usually we have a budget, and sometimes the budget is given, and also sometimes nobody knows where the figure is actually coming from. And that's the problem we are focusing today. And usually the project cost control controls any contract with change orders, claims, etc. against the budget planning. And we can always say how much budget is remaining in our project. But often we can't answer the question, how good is the budget? And therefore we need a risk management approach. Risk management on the left side has three main components, which is the base cost, the cost if everything goes according to plan, the risk, of course the risk part, uncertainties, and the escalation, which is the future inflation rate. And as written here in brackets, range, the information comes in a range, which means we have here on the right side a distribution with the total cost potential of the project, best cases on the left side and the worst case on the right side, and the most likely case somewhere in the middle. Many scenarios that might occur in our project are listed here, depicted here in this curve. What we can do now is we use the budget and just put the budget into the diagram here, and this white dot depicts the budget. And you see now we have here an area, the green area, where all the scenarios in the green area are covered by the budget, and in the red area we have an overrun area, scenarios which are not covered by the budget. And so we can see that the budget has some kind of probability. In our case here in this example, 80% probability that the budget will not be exceeded. And you see this is some very important information to see how robust our budget is. That leads us to the second point, the problem definition for major infrastructure projects. Usually, if you have risks that will occur, they have a risk impact that will lead in many cases to our schedule delay, and this will cause severe cost overruns. I think we all know the problems we have here, and we're facing really cost overruns, and this is also a problem we have in our basic management structure. What you want to see here on the slide is now the standard approach to project management. We have a base cost on the left side. We have risks that might be assessed, and we have a risk, also cost potential of risks, and on the right side the schedule. And those elements are treated in most cases independently. That means we have sometimes aggregation of base cost and risk which lead to a project cost in a single figure here, a deterministic result, and as you can see there's no information about any uncertainty in our cost potential. The same on the right side for the schedule. We have a deterministic date where we complete the project without any information about uncertainty. This leads to a question I want to ask you on the next slide. would you wade across a river with an average depth of 1 meter? Of course not. If your life is at risk, you want to know where the river is deep or we have some shallow parts of the river. So this is the, I would say, the basic problem we're facing here. And but if you look at the upper graph, you see this graph is like an average river. Everything is the same depth, and that's what we do in our project in general. We just assume that everything goes according to plan. There's no uncertainty, and we can just walk through the whole project without any problem. Of course, this is not the case. This is why many of our projects doesn't come in the right time or the right cost. So what do we have to change is the question, to make it an integrated model connecting cost and schedule. So first of all, we need to also assess the potential time impact of our risks, schedule impact. Connect those risks to the schedule activities. So we get a risk-loaded schedule. Then of course we can see what the completion date will be with uncertainties, but we also receive potential completion delay caused by the risks. And now we can connect it to a cost side, we can connect it to the time-related costs of the project and get information about the potential delay costs, which are added up with the risks and the base costs, so we get the full information about the project costs. And this comes in a range, of course, because we consider uncertainties. And now we can, as we have seen before, evaluate our budget, how good the budget is, how much cost does the budget cover in our project. The same on the right side, we get information about the uncertainty of completing the project, and we can answer the question, how high is the probability that our target date will be exceeded or not exceeded? Yeah, when you put all together in this model, you get some results, and this is usually the results you will receive. That's the project here as an example. I would like to explain you this graph. On the horizontal axis, we have the total project cost in million euros. Vertical, we have the probability of not exceeding a certain figure of money. And the first vertical line, the blue line here, depicts the cost estimate, the standard cost estimate, the single figure, 747 million euros in our case here. Then we have that blue curve that depicts the uncertainty in our base cost. There's not any risk considered, it's just the base cost, uncertainties for quantities and unit prices. And we have the first information here, so we can say there's an 80% probability that 791 million euros will not be exceeded. And you see, this is exactly the coverage. We cover 80% of the scenarios in the blue curve by taking, for example, 791 million euros to our base cost budget. From base cost to risk, we just jump to the red curve, and you see it's more skewed. It means risk bring in uncertainty. We cover more potential cost potential at our horizontal axis down here, and you see it adds quite a large part of money here, the risks. So the last step is adding escalation of future inflation rate from the red curve to the green curve. And you see this is now the depiction of the total project cost. And same here, there are two ways now to determine a budget. The first way is the way which is quite I would say, a good approach. It means we generate first a curve with our assessment and then talk about the robustness of the budget we want to have. So for example, if the goal is to have a 80% probability that the budget will not be exceeded, you just look at the graph here, go to the green curve and see the budget should be around 1.1 billion euros, and that will have an 80% probability that the budget will not be exceeded, which means a good coverage. In the second case, we have a given budget. That's often the case in our project in Europe, and we just now can evaluate how good the current budget is. So for example, our budget is 1.005 billion euros. So we just go down that black dotted line here and see where it crosses the green curve, and now we can go to the left and see it's about 11%. So we have only 11% chance that the budget will not be exceeded. So that's not a good figure, of course. We've got a high chance of 89% that scenarios will be above our budget. As a risk manager, I would just recommend in this case to increase the budget by about 98 million euros. So we have this will lead us to a coverage of 80%, which is a good one, and we have only a small chance of overrunning the budget. Yeah, this leads us to the last point, the digital project risk twin. This slide shows us the approach for the project risk twin. We have 3 sections here. On the left side, input. In the middle, the project risk twin. And on the right side, the output results of such a process. What goes in is always the cost estimate, Excel, whatever is used, the schedule, P6, MS Project, and also the risk analysis and the budget planning. In the middle, as we have seen before, there's a risk register in the middle, and all those risks here depicted by a triangle showing the uncertainty in those risks are now assigned to both sides, to the schedule part on the left side, to the activity, and also on the right side to the WBS, to the level where they belong to. If this is done, we can simulate the schedule, and of course we now get a result for a certain milestone, which is a distribution. And as seen before, we can now evaluate the target date and see what kind of delay might be caused by risks. The delay here, depicted by the red area, is now linked back to the risk register and connected with the time-related cost, the delay cost per day, for example. And now this goes back to the WBS as a separated risk. So we have a delay risk in here too. Now the schedule and the WBS is completed. So we can now simulate the WBS with all the components in here. And we get now the information in a curve about the total project cost, the cost potential of the project. And as seen before, we can now evaluate our budget, how likely we're going to exceed it or not exceed it. Finally, at the end, on the right side, we have our outputs, our results, which come in dashboards, which is a good way to depict the information and condense information. There's one dashboard for the cost approach. You see here the graphs in here, and also the cash flow, sensitivity analysis, range diagrams, tornado charts. And on the second one, the same for the schedule impact, all information for the schedule and the risk that might change the schedule. Let me show you some example of a model done in the software Riyadh. In this case, you see on the left side the WBS with risk in here. On the right side, the schedule, and now the risks are connected by using drag and drop to a certain schedule activity. And you see some details down here. In this case, we have connected 2 owner risk and 2 contractor risks to our certain schedule activity. The next screenshot is a bit more in detail. We have picked a certain activity here, TBM North First Tube, and all details are down here. In this case, we have 4 owner risks and 1 contractor risk connected to our activity, and you see details here about the potential time impact in a range for each of those scenarios, and of course to the right the risk name of those items. The last screenshot gives us a big picture of such a model. On the left part here you see the WBS structure with all components, base cost components in blue, the red are separate single risks. Then the second part shows the results for the total project, a tunneling project in this case, total cost with the uncertainty, escalation, risk, aggregated, and the base cost. The third part is the schedule view as you have seen before, our risk allotted schedule with all risk in here and information to our completion date in a range down here, and also the delay which might be caused by risk impact. The last part on the right side is a tornado chart which depicts the sensitivity of the biggest risk in the project, and it shows you how risk can change the cost or the completion date in your project. And of course you should use such diagrams to pick the risks you want to mitigate or change using mitigation measures. To summarize everything, as seen before, we use dashboards. With dashboards show all information from the analysis in a very condensed way. On the left side for cost, on the right side for the time. And again, you see the graphs we just discussed today. Again here, the S-curves, cash flow, the range impact diagrams, sensitivity charts. So you can just see what kind of elements you want to use for your mitigation and for your measures you want to implement to keep your project on track. That's all for now. Thank you for listening.